Nail polish is a billion-dollar industry, and it's all thanks to chemistry.
Beauty, it's all around us, and sometimes we want to imitate beauty through makeup or nail polish. But how do we understand exactly what it is that we're looking at? Well, through science, through chemistry. And one of the things that we look at when we look at nail polish is sugar, the glucose molecule. A glucose molecule, as you'll remember, is a sugar structure that is composed of carbon, hydrogen, and oxygen. When we just have one glucose molecule, it is known as a monosaccharide. When we have one monosaccharide bonding with another monosaccharide, another one, and another one, and another one, and so forth, we can make long chains called polysaccharides. Now, today's example is regarding nail polish. Polysaccharides are so long, they're actually known as macromolecules. Now, let's break down. How is it exactly that they're bonding? That makes a strong bond so they don't come apart easily, like something like this. I'm sure I can drop it. Let's take a look. Let's break down glycosidic bonds.
A glycosidic bond is the joining between a carbohydrate or sugar molecule. Glycosidic bonds are identified by using the Greek symbols alpha or beta. Let's start with first looking at a single alpha-D glucose molecule. Notice the position of the hydroxyl group written as OH. We immediately know this is an alpha-D glucose molecule because the hydroxyl group, OH, is located in the downward position of the molecule. Now look at the beta-D glucose molecule. Notice the hydroxyl group, OH, is located in the upward position of the molecule. Let's look at what happens when two alpha-D glucose molecules bond. The hydroxyl group, OH, is removed from the first molecule, and the hydrogen is removed from the second molecule. Now the remaining oxygen from the first molecule bonds to the remaining carbon from where the hydroxyl group was removed from the second molecule. Through the process of dehydration, water is removed to join these two molecules together and forms a new molecular bond.
As you saw, we went ahead and built a bond by removing water. You can recognize this as dehydration. I like to look at back and forth so I can really understand the glycosidic bond. If we use the addition of water, hydrolysis, we can actually break the bond. Let's take a look. H2O. We can add the hydrogen to the oxygen to make that hydroxyl group. And the remaining hydroxyl group we can go ahead and add here. As you can see, we have broken the bond.
More than 1,000 glucose molecules are bound together by oxygen to form a macromolecule of cellulose. In our nail polish example, nitric acid is added to a glucose molecule and forms nitrocellulose. Nitrocellulose mixed with a solvent such as ethyl acetate will provide a flexible yet durable thin film. Nitrocellulose is a key ingredient in nail polish. Nitrocellulose helps form a hard film over the nail polish to prevent chipping. It is a mixture of liquid, nitric acid, and tiny cotton plant fibers. Nitrocellulose is a highly combustible material that is also used in making dynamite. In a bottle of nail polish, nitrocellulose is dissolved in ethyl acetate. When polish is applied to nails, a chemical solvent, ethyl acetate, evaporates. When the ethyl acetate evaporates, it gives off a familiar chemical smell, and the nitrocellulose is left behind, drying into a solid state as a film on the nail. When nail polish remover ethyl acetate is applied, it turns the nitrocellulose back to its liquid state, which allows the polish to be removed from the nail.